Hello students, today we will discuss about the rolling contact bearing. This is the revision lecture, so I want to revise some important terms in rolling contact bearings. We know that basically bearings are of two different types, that is rolling contact bearing and sliding contact bearing. In rolling contact bearing, the friction is very less, but in sliding contact bearing, friction is very high. So in sliding contact bearing, lubrication is required. If we see the basic diagram in rolling contact bearing, this is the inner race, or it is also called as inner ring. This is called as outer race or outer ring. Then these balls are provided. Spherical balls. And for fixing these balls or for maintaining the position, here cage is provided. This part is called as cage. So in this way, these four parts are important in case of rolling contact bearing: outer race, inner race, spherical balls, and this cage. If we see the designation in case of rolling contact bearing, the rolling contact bearing designated by number. First number, second number, third number. This first number indicates the type of bearing. This second number indicates the series. This third number indicates it is related to diameter of shaft. For example, if bearing is 6,1,10, then this is first number and this is deep groove ball bearing. Second number is series. If one number is there, then this is light series, and this 10, if it multiplied with 5, then 50 mm is the diameter of shaft. So if we consider, this is the bearing and this is the shaft, then this diameter, this is D, and this diameter we are getting by this number 10 into 5, that is 50 mm. So this shaft diameter and inner diameter of bearing is same, that is 50 mm. If we see the design procedure of bearing, then design procedure is nothing but selection of bearing from manufacturer's catalog. So if we see the manufacturer's catalog, then this manufacturer's catalog is nothing but, in that catalog the information available is like this. So here the bearing number is provided like 6406. All these bearings starts from 6 number, that is deep groove ball bearing. Here bearing dimensions are provided, that is bore diameter, outside diameter D, and width B. If we see this diagram again, then this is the inside diameter, then this is the outside diameter, and this is the width of the bearing. Basic capacity, that is static CO, this is in kilonewton. 20, for example, for 6406 CO is 23.60. Dynamic value is also available, that is C in kilonewton, that is 43.60 kilonewton, and limiting speed, that is RPM, is 11,000 RPM. So in this way we see the different types of bearing. If we see this number, that is 64, sorry, or second bearing, that is 6007. So in this case 6 is type of bearing, then 0 is series, and 07 is related to diameter, that is if we multiply 07 into 5, that is 35 is the bore diameter. So if we see this, focus on the second number, so 60, 62, 63 and 64. So 0 means this is related, second number is related to series. And what is the series? Series is nothing but the load bearing capacity of the bearing. If 0 number is there, then this is extra light series, that is load carrying capacity is very less. If 2 number is there, then light series, the capacity is more than this extra light capacity. Then 6 3, this 3 is medium, and 4 is heavy series. So 6 4 type of bearing is having the load carrying capacity is maximum as compared to this 3. So 0 2 3 and 4 becomes the 4 types of series are available. The first step in the calculating or selecting the rolling contact bearing from manufacturer's catalog, first step is calculate the radial and axial loads, that is FR and FA, acting on the bearings. So basically two types of loads are acting on the bearing, that is radial load and axial load. This radial load acts due to the weight of the component on that bearing. That weight comes on the shaft and that is transmitted on the bearing. And if we consider if we consider the shaft, on this shaft, if gear is mounted and this gear is having helical type of gear, then due to, in case of helical gear, it produces the axial force which is parallel to the axis of the gear. And if the bearings are provided at this location, so two bearings are there for supporting this shaft, so this axial force is directly affect or directly comes on this bearing, and here bearing having that axial force. So force produced in case of helical gear, axial force, that is directly acting on this bearing. So this force is considered while designing or while calculating the FA value. Second step is to determine the diameter of the shaft on which the bearing is to be mounted. So we must know the diameter of the shaft on which the bearing is mounted. Third step is select the proper type of bearing for the given application. So for example, if we see the table that is available here, again manufacturer's catalog. So select the type of bearing. For example, if radial and axial loads comes, then deep groove ball bearing is suitable, and deep groove ball bearing starts with 6. And always we start with extra light series, that is 60 series. And if our diameter is 35 mm, then we prefer 6007, this number or this type of bearing for starting our design. Fourth step is selection of bearing is done by trial and error. To begin with, a bearing of extra light series is selected for the known shaft diameter. As I already tell, we start with 60 series and then 62, 63 and 64 if the 60 series fails. Fifth step is find the values of basic static capacity, that is CO, of the selected bearing from the catalog. That is, find the value of basic static capacity CO of the selected bearing from the catalog. So again we see the manufacturer's catalog, and if our bearing is 6007, then CO value becomes 10.20 kilonewton. This is the CO value for our 6007 type of bearing, this 10.20 kilonewton. Then sixth step is calculate the ratios, that is FA upon V into FR and FA upon CO, where V is the ratio factor and this V value becomes 1 for inner race rotating and 1.2 for outer race rotating. We already see here in this first diagram, that is this is inner race and this is outer race. So when this inner race is rotating, generally inner race is rotating in this type of application. Here inner race is rotating, but in case of hollow shaft, if shaft is hollow like this, so at that case bearing is mounted on inner side and this outer race is rotating. So this is the case. So V value depends on the, or ratio factor depends on whether inner race is rotating or outer race is rotating. So V is equal to 1 for inner race, V is equal to 1.2 for outer race rotating. CO is basic static capacity, FA is axial force, FR is radial force. So we calculate these values. Next step, 7 number step, find the values of radial and thrust factor, that is X and Y, from the catalog. The value depends upon the ratios FA upon V into FR and FA upon CO. So for that purpose, if we observe one table, that is so if we observe this table, so here FA upon V into FR we already calculated, and if we see the E values, for example our FA upon V into FR value is 0.23 and 0.23, and if we observe that is 0.23 is which is less than 0.24, so we prefer these values, and FA upon V into FR we calculate and compare with E values. So for that purpose we also know the values of FA upon CO. So first calculate FA upon CO. If that value comes like this 0.07, then you check the value of 0.27 for E, and if your value is FA upon V into FR is 0.25 for example, which is less than 0.27, then you select these values 1 or 0, or if your value is greater than 0.27, this FA upon V into FR value is greater than 0.27, then you prefer, for example if your value is to 0.29, which is greater than 0.27, so you prefer X is 0.56 and Y is equal to 1.6. So in this way you select this radial and thrust factors, that is X and Y. Next step, for the given application find the value of load factor or application factor Ka from the catalog. Again one catalog is available, so in this catalog you prefer the value of, or you select the value of Ka, that is load factor. For example precision type of gearings is there, then 1 to 1.1 is the Ka value. If your gear is commercial gearing, then K is 1.1 to 1.3. If application with poor bearing seals, then 1.2. Machinery with no impact, then 1 to 1.2. Machinery with light impact, 1.2 to 1.5. And machinery with moderate impact, then 1.5 to 3. This is the value of Ka. Then ninth step is calculate the equivalent dynamic load by using the relation PE is equal to in bracket X into V into FR plus Y into FA bracket complete into Ka. Here x and y values we already calculated or selected from the table. V is the ratio factor. We already see whether inner race is rotating or outer race is rotating. Depending on that, we put the values. Fr and Fa we already calculated, and K and now we already selected from the manufacturer's catalog. So depending on that, we get the value of equivalent dynamic load, that is PE. Then 10th step is, depending on the application, make the decision about the expected life of the bearing and express the life in million revolutions, that is L10. So for that purpose we select that from one information which is available like this. So bearing life for automobile applications, if a vehicle is automobile cars, then life becomes 50 million revolutions. If trucks are there, then 100 million revolutions. Railroad cars, then 1000 million revolutions. And if we see the applications like in terms of hours, how many hours it goes. Then for example, if application is machine used for short periods or intermittent and whose breakdown would not have serious consequences, for example hand tools, agricultural machines, then cranes, erection shops, domestic appliances, then generally bearing life becomes 4000 to 8000 hours. If machine working intermittently and whose breakdown would have serious consequences, that is conveyor plants for the flow production, lift machine tools, cranes for piece goods, then for that purpose number, that is life in hours, is 8000 to 12000. Machines for use 8 hours per day and not always fully utilized, stationary electric motors, general purpose gearboxes, then life in hours is 12000 to 20000. Machines for use 8 hours per day and fully utilize, ventilating fans, cranes for bulk goods, counter shafts in gearbox, machines for engineering industry, then 20,000 to 30,000 hours becomes the life. Machines for continuous use 24 hours per day, mine hoist, compressors, pumps, separators, machines in continuous operation, onboard naval vessel machines, etc. Then life becomes 40,000 to 60,000 hours. Next is calculate the required basic dynamic capacity for the bearing by using the relation, that is L10 is equal to in bracket C upon PE bracket raised to A, where this A is constant and that depends on type of bearing, that is ball bearing or roller bearing. So what is that? If we observe this diagram, so here balls are provided, and in place of these balls, if we see the side view, then balls are provided, but in place of these balls, if we provide the rollers like this, so that type of bearing is called as roller bearing. That type of bearing is called as roller bearing. And in that roller bearing, and for that roller bearing, this A value is different, that is 10 upon 3. Then next step is check whether the selected bearing has the required basic dynamic capacity. If not, select the bearing of the next series and go back to step 5 and continue. That is basic dynamic capacity. You compare the C values with that manufacturer's catalog value, and if that C value is not comes up to that manufacturer's catalog value, then you do the next trial, that is step number 5, and continue that. If necessary, calculate the equivalent static load by using the relation PO is equal to maximum for that is XO into FOR plus YO into FOA or FOR. See both the values, whether this calculation is maximum or whether FOR value is maximum. Select that, and you prefer that value for PO. For the safety of the bearing against the static failure, CO must be greater than or equal to PO. So here in this way we complete our discussion of revision lecture for rolling contact bearing. Okay, so we stop here. Thank you.